Hello, my name is Adriana Morono, and my scientific research project this year was using zebrafish as a model for obesity and evaluating the harmful effects on the fish and on their offspring. This research project was completed in conjunction with the Liberty Science Center's Partners in Science program, as well as with mentors from Jose Marti STEM Academy. I would like to give a big thank you to my mentors and to the coordinators of the program for assisting me in completing this research study. Obesity has been widely regarded as one of the biggest issues in the United States at this time, and numbers of this disease have basically doubled since the beginning of the 2000s. But what not many people who have obesity know is that it does not only affect their phenotype or the way that their body expresses themselves outwardly, but also the inner workings of their body, as well as the effect that it has on their offspring and the effect that it has on their brain function. In this study, zebrafish were used as a model organism, and many people might ask, why zebrafish? They are so small on a comparative scale to humans. But zebrafish actually share a lot of genetic makeup with humans, especially in their adipose tissue, which you can see in this picture in this picture right here. You can see that this part, this gut part, is very similar to the humans, basically the fat portion of the human body. This is why these zebrafish are so good for these type of studies. The zebrafish were subjected to a high-fat and overnutrition diet over the course of 8 weeks, and their triglyceride levels were monitored, their glucose levels were monitored, as well as the tail deformities in their offspring. And as you can see in these pictures down here, there's a big difference between the control diet and the high-fat carbs diet. You can see that there's very noticeable inflammation in both the skeletal model and the fluorescent microscope model. The yellow part represents the fat on the zebrafish, and you can see how much it increased from having a normal shrimp brine diet to having a increased calorie diet. And you can also see it in these pictures up here. Here you can see it more clearly in the general makeup of the zebrafish. And in this picture right here, you can see that the zebrafish on the top was fed a normal shrimp brine diet, and it kept its stripes horizontally, meaning that its outward phenotype did not change. But as you can see on the bottom, the fish has almost lost the color in its stripes, and it has also lost the color completely in the stomach part. And you can definitely see that there has been a very big increase in fat on the second zebrafish. This can also be translated onto humans in a way. And as you can see in this diagram, this is a diagram that displays the way that obesity affects the zebrafish. And as you can see, FFA levels rise as well as AT, and inflammation in combination with steatosis leads to obesity-related disorders in the fish. As you can see here, this is the data that the researchers collected on the study, and figure one displays the body weight of the male zebrafish over the course of 8 weeks. And here is displayed the control group in black and the overnutrition group in white. And you can see a lot of difference between the control group and the overnutrition group, as not only in figure one, but also in figure two, which is the body weight of the female zebrafish. So this was not only limited to sex, the obesity affected both the male and the female zebrafish in a very similar way, I would say, especially in the um error bars. You can see a lot of the same like stretch between both the female and the male zebrafish in terms of the body weight. And here in figures 3 and 4, we have the data regarding the offspring of the obese zebrafish. And in figure 3, we have the hatching rate over the course of 8 weeks. And in these error bars, it is displayed that it was very random, the amount of birth that the obese zebrafish were exhibiting. It could be on almost at 25% or at 100% hatching rate. It was very randomized, which can directly translate into a randomized miscarriage in the obese zebrafish, while the control zebrafishes were very much on a smaller scale with the error bars. So there was more, they were all the control zebrafish were on the closer side to at least a 50% hatching rate, and most of the obese zebrafish, the error bars go bordering onto the 25% hatching rate. So we can see a lot of discrepancies in this data and a lot of possibilities for error in the obese zebrafish. And on figure 4, we see the direct product of the hatching rate, which is the actual offspring. And here we see the difference between the control and the obese group. In here in this figure, we can see that this is the percent of tail deformity between the control and the obese zebrafish. And as you can see, the obese zebrafish had a very wide range of tail deformity in the data, and the control only had less than 20 tail deformity at all time, while the zebrafish that were obese had a high of almost 70% of tail deformity in their offspring. And here in uh, pictures D, E, F, and G, you can see some of the visual representations of these tail deformities, where some fish were even born with no tail at all, and they were just very deficient from the beginning. And this can be directly translated into human genome. And here in these figures, we have the glucose levels in the offspring and the parents. And as you can see, there is a very big difference between the control group of the parents and the obese group of the parents. You can see that they have very different numbers in glucose as well as in the male and female offspring. And on the bottom, you can see in figure 6, the triglyceride levels in offspring and parentfish. And although the results were a little bit closer in this aspect, it was still a difference between the male and female offspring as well as just the general triglycerides in the parent fish. And as you can see, these problems that started in the obese zebrafish were directly translated into their offspring without their offspring even being fed anything. Just by being born from these obese zebrafish, they were already condemned to having high glucose levels and high triglyceride levels. In conclusion, this study was very important because it displays how these numbers and this data can be translated into human awareness for obesity, because not many humans know that these things can happen inside their body and not only affect how they look, but affect the lives of the children that they may produce. And something very interesting that these researchers found out was that the zebrafish were also exhibiting very low brain function, given that the normal zebrafish were moving around quickly around the tank, they were responding to stimuli, and they were readily looking for food, while the obese zebrafish were moving very slowly, they were moving very close to the bottom of the tank, and they were taking much longer to reproduce. And in terms of reproduction, their offspring also only lasted about a week, and most of them did not live past the week because of the immense amount of deformities and high levels of different sugars and triglycerides that they had exhibited because of their parental fish, in contrast to the normal zebrafish offspring, which live very much past the week. And in conclusion, the zebrafish were greatly affected internally and on a neurological level, and this can be translated onto humans. In future application, I would like to complete this project on a physical level, and also I would like to add a weight loss supplement to this experiment to see if it will benefit the fish in any way, if it will benefit their brain function. I am from Cuba, which is my home country, and in my home country, they have a type of plant called ananato. And ananato has been known to cause many medical sort of miracles, and it's very good for dermatological problems. It's very good for yeast infections, and it has shown in Cuban medical studies to increase brain activity. This is why I'd like to test it on the zebrafish to see if it has adverse effects on them, or if it can actually help them lose weight and help them to even maybe be better in triglyceride levels and glucose levels and in just overall brain function than the normal zebrafish, to see if this can actually be an alternative treatment for humans. And this is the end of my presentation. I hope that you enjoyed it. Thank you very much.